Alright, so here's part 2, the notes. We got 3 more theorems, okay? This is 2, 3, 4. But to be honest, these two are just the biconditional, so they're very similar. So let's dive into it, okay? If a diameter or radius of a circle is perpendicular, okay, perpendicular, remember the symbol, boom, perpendicular to a chord, then it will bisect the chord and its arc, okay? It's doing two things here, bisects the chord and the arc, okay? Let's draw a picture of what this looks like. Boom, draw a little nice circle here. Make it a little bigger. Shoot. Okay, circle. Boom. Okay, let's draw. Okay, I'm gonna draw a chord here. Okay, boom. This is a random chord. Let's call it XY. Chord XY. And let's say I draw this diameter here. And as long as this diameter, it has to be what? It has to be, starts with a P. Has to be perpendicular. So let's say it is perpendicular. Now, if that's true, oh, my notability froze. Okay, if that is true, okay, let's call this AB. Then, if it is 90 degrees, that is saying it's gonna bisect the chord, which means boom, boom is congruent. Oh, we might as well call this like Z or something. Let's call this Z. Call it here. Z, okay? That's congruent, and also these arcs are congruent, okay? Which is basically what they're trying to say right here, okay? So ideally, XZ is congruent to ZY. The segment and also arc XB is congruent to arc YB, okay? These are both true as long as the diameter is perpendicular to the chord. So really, I can just write down give you a shorthand here. If a diameter is perpendicular to a chord, well, what does that mean? I'm gonna put this biconditional statement. This would then state that the chord and the arc are bisected. Okay. Once you have this is the key. Okay, it needs to be perpendicular. If you see it's perpendicular, okay, it's gonna cut this in half evenly, cut the chord in half, and it's gonna cut the arc in half. Okay. Theorem number 2, we're not gonna waste too much time on it. It is the same thing, just the converse. Okay, this one is saying if you're given, I'm gonna draw it just for kicks, do a real quick one. If you're given that the arc, let's just say you don't know that it's 90 degrees. Okay, the only thing you know is that boom, these are congruent, right? And if that's true, if those two are congruent, then boom, it's perpendicular, right? That's all I was saying. Okay, it's saying the converse of it. And of course, the arcs would be congruent as well. Okay, so boom, highlight, star this, part of the shorthand version. If that diameter is perpendicular to the chord and the arc, they are bisected. Okay, they're cut in half. And then vice versa is true as well. This last theorem here, it's not used too often. It is used sometimes, but it states that in the same circle or in congruent circles, the two chords are congruent. So two chords, look at this diagram, two chords, F, G, J, H. Those two chords are congruent if and only if they are equidistant. So the chords, they have to be the same distance from the center. And you always measure this distance, okay, with a perpendicular line, okay? So this distance, if XL is congruent to LY, okay, XL right here, LY, if they're congruent, well, what does that mean? That will then state that, I'll do this arrow, it would then state that FG, the chord FG is going to JH, okay? That is what that is stating, okay? And of course right here is just showing the biconditional, okay? So either or, okay, if you know that the chords are congruent, if the chords are congruent, FG and JH, if they're congruent, then that means this equidistant segment here, they are the same as well, okay? In shorthand, I mean, you want to write this, you can basically say congruent chords, okay, the chords are congruent, boom, then it's gonna have congruent segments perpendicular from the center. It's kind of wordy, not a fan of this. Okay, but the key part has to be perpendicular. Okay, you can't just say, oh, look, boom, from center to that and to this, right? You can't compare that. It always has to be compared forming a perpendicular line. Okay, so just keep that in mind. All right, let's test out these theorems. Okay, example. In circle O, CD is perpendicular to OE. Okay, we have that here. CD is perpendicular OE. Okay, that's good. Let's kind of look back at our theorems. Ooh, perpendicular, huh? What does that mean? Huh? What does that mean? Okay, it's gonna bisect. Okay, just kind of preparing ourselves. OD, overdose. Overdose on not drugs, on homework assignments, so we can be smarter. Okay, CD, 24. This whole thing is 24. Okay, find OE. Find OE, OE. Okay, a diameter or radius perpendicular to the chord bisects the chord. Oh, I'm just giving you the answers. Okay. We know that this is perpendicular, thus CE is congruent to ED. We know that. We know CD, the whole thing is 24. So ED is just 12, right? Just half of it. Oh, what type of triangle do we have, guys? Boom, right triangle. Okay. You use Pythagorean theorem here. Doom, 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 boom. This was 15. Oh, snap. This is 15. This is 12. This is my OE, right? OE is right here. Oh, it's actually a 3, 4, 5. You guys didn't know that. Is it a 3, 4, 5? No, it's not. It's not. It's not. Oh, it is. It is. It is. Yeah, it is. Technically, this x right here, OE, equals 9. Okay, it's a 3, 4, 5 ratio. 3, 4, 5. Where that works for 9, 12, and 15, which is what we have. If you're not used to 3, 4, 5, right? Pythagorean theorem never hurts. Boom. Boom. Work this out. X would be 9, okay? Yay. Alright, some examples. I'm gonna do 1. You guys are gonna try 2, 3, and 4 on your own, okay? Number 1, in circle A to our right. Okay, circle A, we identify the name of a circle by the center that we label it. So circle A, the diameter is 12. CD is 8. Where's CD at? CD, boom, CD is 8. The arc CD is 90. Where's the arc CD? Boom, this arc here is 90. Find each measure, round to the nearest hundreds. Okay, DE, where's DE at? Okay, DE is right here. I see you, DE. Boom, Ed. Okay, you need to find what that arc is. Oh, that's pretty easy. What's the whole arc? The whole arc is 90, right? The whole arc is 90. This we know. Alright guys, please check your answers. 3 is actually pretty tricky. Check out number 3. So we're actually supposed to create this right triangle here. Okay, very tricky. Okay, it's a math savvy move. Okay, you have a right angle, we know that. So you can create AC here. Okay, you create AC, that's your radius. Okay, your radius wasn't actually given to us, but we were given the diameter here. The diameter is 12, so radius is half of that. This right here is 6, okay? So basically, I just redrew this small triangle right there. You have Pythagorean theorem. You can solve for your AF, which is x. You get 2 radical 5, okay? Number 4, for some reason on your worksheet that you guys have, it seems like I didn't give you this information, like it didn't print out. I don't know why. But please add this, so Hopefully you guys were watching the video. But you can't do this problem unless you add these two information. Once you have that, you can see since CD and CB right there, since they are congruent, if they're congruent, that means the distance here, they're equidistant. So you can set GQ is congruent to EQ, solve for X, and boom, you are done. Okay, please let me know if you have any questions or concerns about this lesson through your homework Google form. Okay.